Hello everybody, and welcome to this talk, which is entitled "LOD-ifying Bibliographical Data Using Free Software," where I'm will be particularly mentioning the CLB Wikibase, which is the last experiment I'm having with the Wikibase software. CLB, as you know, is the Czech literary bibliography. For the last 2 years or so, I'm working with that software, producing linked open data sets with lexical and bibliographical data. And yes, I will mention some of these experiments. This is the outline of my talk. First, some preliminary considerations. Why do we want to use that software and what are our goals? Then I will highlight some previous work with that. One of the experiments has been carried out in the framework of a larger project, and the other ones are at a purely experimental stage at the moment. If you want to see more presentations or publications about them, go to my user page at Wikidata. Yeah, and then we will focus on the latest experiments with the CLB. Some preliminary results, and then how we could work more on this in the framework of the envisaged cost action in the DARIA Bibliodata working group. And then some summary and outlook, final remarks. So we start from the fact that we have a bibliographical data set, and we want to produce, of course, fair open data. And we want 5-star linked data. If you don't know these concepts, you may refer to these links. And we also want a workflow for that, which is accessible to anybody. Now, I like to call it a DIY workflow. That is, we will use only software which is free and open source. And since we can't spend money on DOIs, for example, and we know that we won't appear in the Web of Science with our publications, we want to connect our dataset to Wikidata, which is the largest existing open knowledge graph at the moment. If we are doing that, we can take advantage of tools which already exist for Wikidata, such as Scholia. If you don't know that and don't know what Scholia can offer to you as of now in bibliometrics, just check it out. And yes, since that is all this is developed in an open community, we might at least contribute by defining requirements. Now, if we are not able to contribute as developers, now as it is my case, now I'm a pure user. Okay, and as soon as we have our data on Wikidata, our data set is seen by other friendly initiatives such as Open Citations. Okay, so why should we use the Wikibase software, and what is that? Wikibase is the software underlying the main Wikidata. So if you have a Wikibase instance, you have something like an empty Wikidata for you, which you might fill with your content and your properties and your ontology items, and also with lexemes. Now, it's also possible to have lexical data now on Wikibase, just as in Wikidata. Wikimedia Germany offers a hosting solution for Wikibase for free. If you have an account, you can, in a few clicks, you have your own Wikibase instance. You have absolutely no hassle with all the administration stuff because Wikimedia Germany is doing that for you. This is at the moment in a beta stage where you have to be invited for as early adopter, and you have to cope with the risk that it is not as stable as it should be, but this is a matter of time. And yeah, in the Wikibase, as in the main Wikidata, you have user and user rights management, you have reversible edit histories, so that you have full control over the creation of your own, maybe noisy data. If you do that, you could do the same thing using the main Wikidata from the first moment on, but then you have less control. For example, you cannot create your own properties within seconds, as you might do with your own Wikibase. In a Wikibase, such as it's the same thing as in Wikidata, every ontology entity you create has then its own page, its own exhibition page, which you can visit and where you can manually edit every single statement. And it is basically the same thing as on Wikidata. All ontology entities have labels, descriptions, and statements. You can access the data using Sparkle, either through an endpoint or through the graphical query service, or you might use the MediaWiki API, which will give you a JSON representation of that entity, of the entity you're asking for. And yeah, around the Wikibase software, there's a very active and interesting community working. There is the Wikibase stakeholder group. There are some Telegram channels where you can find support almost immediately. And then there are the community managers working at Wikimedia Deutschland, which also have interesting actions. So the vision behind that Wikibase is visualized like this, no? On this strategy page you might visit. You might know that Wikidata is not old. It is 10 years old, and the first purpose of it was to provide a central data object that would link the content of all different language Wikipedias and content of other Wikimedia projects just to this central point, now instead of having a lot of links organized in that way. But in the meantime, it has become much more. Now we have a lot of entities which don't correspond to a Wikipedia article. And yeah, this is like the vision, no? That you might have a lot of Wikibases that are actually federated to the main Wikidata. You can also have federated Sparkle queries in order to access the content of your own Wikibase or any other Wikibase and the main Wikidata at the same time. And then these gray dots are what is normally known as linked open data cloud. No? So this is instances of LOD databases which are not Wikibases. Okay, so some previous work on this. The one that is most advanced is the LexBib Wikibase. You might visit this under this address. This has been developed in the framework of the Alexis project. Yeah, and what we had there was a large Zotero collection of lexicographic articles. We're talking about the domain of lexicography here, including full texts. Yeah, you might visit that here. And we wanted to create something more than just another bibliography. We wanted a knowledge graph of our domain. Now, I will now explain a bit more in detail what I mean with that. So, of course, in Zotero, everything is literal values. No? As you might know, for example, the authors are literal values. So this is the most tricky part, of course. You have to disambiguate the authors, no? Or to normalize, like in the library science speech now. And for that, we're using OpenRefine, and which also can be connected to your own Wikibase, not only to Wikidata or to VIAF, no, but also to your own Wikibase. Around Zotero and Wikidata, this little microcosmos, there's a lot of related work. There are some tools, some generic export tools from Zotero to Wikidata quick statements, which is another Wikidata-related tool. There's a publication metadata scraper for scraping metadata from Wikidata into Zotero. There are some relevant tools for Wikidata. The Wikidata author disambiguator. This works for publication metadata, which is already on Wikidata. And then there's, of course, Scholia. And then there are these Python packages called Wikidata Integrator or Wikibase Integrator, which is what I'm using for sending content to Wikibase or to Wikidata, respectively. Then you can also use this package for reconciling against your own Wikibase. And then there are some other tools that are interesting in this context, like this citation tool, which works with Wikidata identifiers, or this Zotero to RDF exporter, which uses the Bibo ontology. So for the Zotero export, in the end, we have built our own export script and then built it into our local Zotero. This gives us a JSON representation of the Zotero item. And this is then mapped to the properties in our Wikibase, which at the same time are aligned to Wikidata properties. And these are aligned to RDF vocabularies. Now, these alignments are found on Wikidata, while the alignment from here to here is found on our own Wikibase. This allows us to receive and send content to and from Wikidata seamlessly, no? Since the underlying data model is the same. It is only about aligning properties and respecting the Wikibase data type, and then it is absolutely, it can be straightforwardly synchronized, or you get the data you don't have on one side from the other, whatever you want, you can do. And this is then the data model for a bibliographic item on our Wikibase. Now, instead of literal values, we have, of course, ontology classes, bibliographical items, persons, which are linked to the item through creator roles. Persons are affiliated to organizations. Organizations have places. Bibliographical items might be presented at some event. The event also has a place. Bibliographical items may be part of a collection, and they have a publication language. No? So this is the basic model we are trying to, and then we are populating this with the Zotero data. And we are also technically prepared for defining citation and review links. Now, this goes from one bib item to another one. We have not started to put this in practice in our catalog, but we want to do this. What we are doing at the moment is to define the link to the subject, which would be a term. We have a controlled vocabulary for this, which I will mention just now. It is called LexVoc, the multilingual vocabulary of lexicographic terms. We have built this, this would be too long now to explain, but it is elsewhere, it is presented, and also it is explained here. What we are doing is we are isolating the text abstract and or text body from the full text PDF using the Grobit tool. And if that fails, then we do it manually. At least we have done it that way in the Alexis project. Grobit works very well, but it has to be a standard article structure that is title, authors, affiliation, abstract, then the text body, then the bibliography. If it's not that typical structure, then Grobit usually fails. And then this text body, we limitize it. We actually LexVoc, we have it in many languages now, but as for now, we are doing this only with English and Spanish text. Although Spacey is easily, provides pipelines for many more languages now. And then we are finding the terms from of our controlled vocabulary in the texts. No? So this is a purely lexical approach at the moment. And we want to come to something which elsewhere is called ontology-based indexing, which is that you take into account the number of edges between found terms on the SCOS graph, no? So that we could define clusters, which should be the topic of the article, and also disambiguate ambiguous matches, no? Because also in our domain vocabulary we have ambiguous lexical items that might be two different concepts, no? Or we might simply use ANIF, which is a very interesting solution. And as soon as we have time, we will look into that. So this would be an example bibliographical item on LexBib Wikibase. I think I have this. No, I'm not going away, but I have this. If I press this now, here I have this here. So this looks like in Wikidata, no? It's the same look. Here we have the backward link to our Zotero item with abstract in English, the link to the full text and to the isolated TXT. This is on the Zotero web platform server. And actually this is now in Czech, no? Since this computer wants Czech, this is now in Czech. And yeah, further down we have then, here we have the authors. Now we import the literal values here, but using OpenRefine against our own data set. Now, if the person previously exists in our data, it is then linked to this item, no, describing that person. But we will still keep the literals here, so that we can conserve the name variant which actually is used for citation. No? And then the terms which are found in the text. Now here you see that it actually will give you the Czech equivalent of the term. If I change the language here, it will appear in the language I want now. But this is the term that has been found 51 times and so on. So this is what we have at the moment. Okay, so the next experiment was very similar but different. Now, Inguma is a online bibliography of scientific publications in Basque language, maintained by a Basque university, the only one which works purely in Basque. It has a graphical online interface where you can query the SQL database at this address. And it has no full text at the moment, but this should change. And yeah, some content has already been transferred to Wikidata. In particular, there is already a property for the Inguma own author ID. And yeah, then Inguma also has the UDC content descriptors, and it contains almost completely all scientific communication in Basque language since 1968, which is when the standard Basque was defined. So here we have something very similar, but the starting data is some other format. No, it is SQL tables. And here under this address, you may find out what's already there with that. This has been carried out using a grant from Wikimedia Basque Country. The data model is also very similar. Now, what we want here is to do a bit, to do also the Grobit task and lemmatizing, finding terms from a controlled vocabulary. And we want to use Wikidata as authority file directly, which is, as soon as we find an author which is still not on Wikidata, we will transfer it to there. Yeah, and the last experiment, the newest one, is the CLB LOD, which is how we call this experiment. Here we have mark data, so this is a third use case with different data in the beginning. And it is, this project is, Wojtek is the head of it now, and he has 650,000 mark records. If we also count the card index to be digitized, it is 1.2 million. But the software should be prepared for that, so we will not have a scalability problem in that respect. Here we have bibliographical items, creators, journals, languages, and countries, and also the UDC classificators, which are expressed in two ways in this mark data, with the decimal classificator itself, and then with the checkout authority file ID for every classificator. So if I click here, I should get to an example record, which looks like this. And it has titles in two languages. So the mapping from Mark is not as straightforward as from Zotero or the SQL database, because this Mark is a complicated thing, but it is possible. Yeah. And we have here the UDC classificators. What we are doing here is we are citing the literal, and as soon as we set up a concept item which describes the concept item, we replace this no value statement, as this is called in Wikibase, with the actual statement. And in the meantime, we have here these literals. No? But we have agreed this week that instead of this, we will use the check authority file identifiers instead of these. But this will be interesting. The next part of this experiment, we have now done 5,000 items now as a first experiment data set. The interesting thing will be to have these content descriptors represented as graph, so that this will allow queries which are not possible at the moment in the actual software used here in the institution, so that you can query for publications related to a concept and the related concepts, or the narrower or the broader, And you can also check if the broader concepts of the most specific one are actually there, which is, yeah, this would be the validation of the cataloging practice. So we already have some applications of this experiment. So this is all the marked data. Now, this, for example, is a problem. Now, this marked citation string, there we have no straightforward way to extract what we actually would need for citing that article. Now, if you want to export that to Zotero, for example, in order to have it for automatic citations in your work, it is not straightforwardly possible. So yes, the experiment is about evaluating the pros and cons of such a strategy. Okay, so we asked ourselves, why should we mirror a mark on a Wikibase, and is that actually interesting for more people now? Wojtek said, people outside his own institution know the Wikidata format better than the mark as it is used inside this institution, no? Because mark is not the same as mark. So this would be one point. The Wikidata format, no, Wikibase format is better for data analytics or data science. And of course, we can federate with or export our content to Wikidata. And we will, of course, do this. The next step will be that we export those creator entities that are still not on Wikidata, but do have the check authority file identifier to Wikidata, so that, yeah, and this will be really an easy task, and we can do it quite immediately. And then, yeah, what I explained, you know, the experiment with the UDC classificators. And here you see our colleague Wojtek, as he is now on Wikidata, no? So something like this, yes, something like this should then exist for all creators in the CLB marked data. Okay, so I'm already at the summary now. Until now, we have 3 use cases for bibliodata LOD-ification using this software. We had different formats in the beginning, but we have also some things in common for all these 3 experiments. We have very simple Python scripts that perform the mapping and the upload to Wikibase. We are using this Wikibase integrator script. If you look at the Python scripts, they are really simple. No? This is, on the one hand, this is due to my limited programming skills. But on the other hand, I think it's worth it, because then other people that might do something similar immediately understand the script. No? You know that if you understand me, no? Okay, so some conclusions are that this kind of task is not trivial, but it's also not rocket science. No? Everybody can do this at home. It is doable for any owner of a bibliodata set without spending money on anything than the laptop and the internet connection. And I think it's very probable that more use cases like that might appear now. And this is actually the kind of thing we are thinking of for one of the working groups in the envisaged cost action. We are planning in the Daria working group Bibliodata. And yes, we hope we will continue with all these experiments in a bigger framework. No? So the LexBib Wikibase, the project that has been the framework of it, has ended, but we think we can go on with it under a new roof, which will be the Clarin K Center for Lexicography, which is about to be created. For the Inguma Wikibase, we are preparing a long-term project application. And the CLB will, since MARC might be of a more general interest, will be definitely one of the topics in the planned actions in the cost action. So until here my presentation, and if there's time, we could, yeah, you just tell me where you want to go back to or what you want to know. Thanks.
Thank you very much, David. And me, as the Wikidata entity, tries to pose a question.
I have 2 questions in one. Is this workflow from Zotero to every step is documented somewhere? So it is easy to, if I would like to put my Zotero collection into this, is it easy, one click, or at least several documented clicks, or figure it out? The second question is that Mark, portion by Mark Explorer contains 3,000 or 3,000 individual data elements. Do you map all these data elements or just a subset?
Yeah, first question. This export workflow fits for our Zotero collection and our Wikibase now. So it will be slightly more work than just changing the namespace of the Wikibase, because it will be your own Wikibase probably. We have here some somehow hacky workarounds that I don't know if you also would like to do this. For example, here we are using Zotero tags for making statements or something like RDF triples already in Zotero. Now I use this double colon syntax for Zotero tags. So this, for example, yes, it is documented. There are publications about this, all the details. You can access them. And yes, you would check what do you want from that, and yes, I think this is doable in a small amount of time. And the second question was, at the moment it is a subset, but the things that were important for our experiments are already there. So this is where I'm in contact with Wojtek, because Wojtek is the one who knows his marked data by heart. No, and this is absolutely necessary. Yeah, there's no generic way of handling Mark. At least I have no library background, but I see it like that. I have looked in the internet for other Mark LOD-ification strategies or projects, and also there, what you find are the mapping tables. No, and these things change. It would be interesting if we had, as soon as we have more use cases, to look at the intersection now. What is common to all of these Mark use cases and what not. No? And the same is true for the UDC. For in the Inguma, in the BAS database, for example, the UDC chapter number 4 is empty, and our colleagues in the Basque country use it for the classificators related to Basque language, Basque culture, Basque country. They just use something with 4 because it was empty. But this is not global. It is just their typical, their flavor, the flavor they give to UDC. No? So I think it will be hard to have a 100% generic method. Yeah.
UDC has another problem that there are multiple additions, and consecutive additions override the meanings of the same notations.
Yeah. So again, the same. No, you have to work together, or you have to be by yourself the one that knows the data set you have in front, no, and process it in a specific way.
Yeah. If I may elaborate a little bit on David, we have basically, provide or have the most common mark fields. Basically, mark that contains plenty of information, but let's say there are 20 most frequent fields, and let's say 100 or 200 of most frequent data elements. And those we have mapped. Definitely for CLB, we never processed any music, pieces and things like that. So this is a part of it. We are completely omitted. So we have tested basically on our data and found most frequent fields, because as David has told, it is basically a sample. It is not something which is finalized, and it is adapted on our, let's say, on our mark. We are using mark in our way, or there might be some, discrepancies with the official mark norms. But I suppose that it might be in any national library or in any institutional version of a mark. There will be always some changes which are given by the nationality. Yeah. But if the workflow is given, then you can simply adapt it to your version of the mark or to your data. Thanks. Yeah,
I have a question based on this answer, because I'm not familiar with UDC or MARC. Since these are adapted international galleries, or you have different versions. When it comes to Wikidata, you're supposed to have one URI that mentions this. How do you differentiate then between, let's say, UDC concept version number 1 and version number 2?
Yeah, I know that at Wikidata,
I suppose it should be one of the property, which version of the UDC is used. From my perspective, there is no way around.
On Wikidata itself, they have not gone into that. UDC is just represented as literal value, the number, and at the moment it is not mapped to a concept. So you can have searches by looking at concepts like, I don't know, Czech literature and bibliographical items that have the same descriptor as literal. So it is not really a conceptual mapping. And this might be a reason, but we can have such conceptual mapping if we see our UDC as a closed universe, no? And on our Wikibase, we are able to do that. Yeah, so maybe last point, if you go to CLB LOD, you have these Sparkle examples where there are some very basic queries, for example, the distribution of mark creator roles, no, which is a very basic example of what we can do there with data analysis, no, with built-in visualization methods in the Wikibase, such as in Wikidata. No, it's the same thing. So this is the distribution of the mark creator roles in the 5,000 data set, or something else very simple is the co-authors of you, Wojtek, in this data set, in this small 5,000 items data set. Now, so you are here, and these are your co-authors in these first 5,000 items, and you have 2 with Gabriela and 1 with these other 3 in these first 5,000. No? So this is just for showing how easy it is to get some visualizations here out of the data, no, with Sparkle. You may play around with this, of course, because this is accessible to anybody. No?
Any other question?
In chat.
In chat, Gabriela is asking.
Yes. You summon her.
Yeah, I will try to summarize, or maybe I will answer to her. Yes, basically, it can be well, I will read the question in Stockholm, but it only can work with the open access data, right? Yes and no, it might work with any data, but this data should be later on published openly.
The license thing. Yes, a Wikibase is necessarily open. You cannot close it. You can restrict the users and the permissions users have, but the data access is always public. So, but Wikidata is always CC0 now, as you might know, but Wikibase content, you can define it as some other CC license, with some other CC license other than CC0, but it is open by default, and Wikibase developers are not interested in creating anything closed, and they would just tell you, no, we won't do a version you can close. So this is something you have to assume.
This is a very good question. So I was just wondering if you will open your mapping of mark, just to see, because I think it was really this idea of comparing mappings, right, to see how people tend to map certain mark fields to Wikidata. So I was wondering if yours is open and where can I look at it?
Yeah, the mapping is, you can look at the Python scripts which do it now. So they read a mark record and they reach to the different fields and do then something. No?
Which one is the one that does that?
Yeah, this is, I can show you later. If not, now we would have to go back to the slide and find the link, but yes, I can show you later.
Thank you.
Any other question or comment? I will double check the chat, but there is also nothing. Okay, so thank you, David, once again for great talk.